Hello friends, welcome to my channel. Now in this video we will complete exercise number 1.3 and the first question is we have to write a decimal expansion of these numbers and we have to write what type of decimal expansion these numbers have, whether terminating, non-terminating, repeating or not repeating, right? So the first one, here we have 36 by 100, that is very easy, the answer is 0.36, we all know. Now this is non-terminating because it stops after 6, so it is terminating. Terminating means it stops after some digits, right? So it is terminating. Now for second one, 1 by 11. If you divide 1 by 11, the answer will be 0.0909 and it will go on. You can write simply is at 0.09 bar. Now you can see here that this is non-terminating because it goes on up to infinite for 090909. So non-terminating. Now when the answer is non-terminating, you have to mention whether that is repeating or not. So here we have a bar, that means these two digits will repeat itself, so it is obviously repeating. Now for this one, first you simplify this, like 4 multiply 8, that is 32, plus 1, that is 33 by 8. The answer will become 4.125. You can simply directly write this answer 1 by 8, that is 0.125, and 4 as it is. Now this number is obviously, this number stops here, so it is terminating. Now for this 3 by 13, now if you divide 3 by 13, the answer will be 0.23069, right? And it will go for continue after this. So the answer is obviously there is a bar, that means this is non-terminating and repeating. So non-terminating and also repeating because it is a bar. Now if you divide 2 by 11, the answer will be 0.1818 and it will go on. So you can write it easily as 0.18 bar. That means this is non-terminating and repeating. Now 329 divided by 400. If you divide 329 by 400, the answer will become 0.8 2 now 5 8225. So this is non-terminating, oh sorry, this is terminating because it stops after 5. So this is the first question. Now we will move on to the second question. Now this is our second question. Here we have given that 1 by 7 equal to 0.142857 and there is a bar on that. Now we have to predict the value of all these numbers without doing actual long division method, right? So let me give an example. If you ever do the division of 1 by 2, the answer is 0.5. Now what if I multiply it by 2 and I will divide 2 by 2, the answer will become 1. If I divide 3 by 2, the answer will become 1.1.5. So if I don't want to divide it, if I directly multiply this number by 2, right? If I direct both side I multiply by 2, this side will come 2 by 2 and this side will become 2 multiply 0.5, the answer will be 1. So here it is 2 by 2 equal to 1. Now if I want to find 3 by 2, what I will do is 1 by 2 equal to 0.5. Now I want to find 3 by 2. I will multiply 3 on the both the side. So this is 3 by 2, this is 1.5. Here we will do the same thing. We will just multiply the numerator on the both sides of the given value. Here we have 1 by 7 equal to this. Now I want to find 2 by 7. I will multiply 2 on the both the side. So if I multiply 2 in to these decimal places, I will get the answer. So 2 by 7 equal to, you can do it on rough pages, right? You don't have to show the process here. 0.142857. You can directly multiply only this part into 2. The answer will become 0.285714, and there is bar also, right? Now for 3 by 7, just multiply this number by 3, you will get the answer. If you multiply this number by 3, here is 1. So if I write the answer is 175,824, and there is bar on this. If I want to find 4 by 7, just multiply it by 4. Here you get 8. So you can write 824,175. Now for fifth one, 5 by 7, multiply it by 5. I am not doing complete multiplication here because I know the value, right? If you multiply it by 5, you get 5 here. So answer will become 582,417. Now if you multiply 6 by 7, you have to just multiply 6 here. Answer will become 241758. This will be the answers. Now here we have third question. The question is we have to express all this number into decimal form. So we have to use a method that we have remembered to express this type of question, that is repeating into and non-terminating and repeating into the decimal expansions. First step is we will assume that let x equal to 0.6 bar. That means x equal to 0.666. Now we will multiply both the side. Here we have bar on a single digit, so we will multiply it by 10. By multiplying 10 on both sides, we will get 10x equal to 10 multiply 0.666. If I simplify this, 10 multiply 666, my answer is 0.666. Now here is a important step. We will separate it in such a way that we can use x here. So let me write the value of x as it is, and I have to write 6 here to make this 6.666, right? Here 10x as it is. Now 10x equal to 6 plus, I can write x instead of this because we already assumed that x equal to 0.666. If I take x on this side, 10x minus x equal to 6, that is 9x equal to 6. So ax equal to 6 by 9. If I cut it, my answer will be ax equal to 2 by 3. This will be my answer, right? In the form of p by q. Now for second one, that is 0.47, and the bar is on 7 only, right? So we will in the first step we will assume that x equal to 0.4777. It will go on. Now in the second step I have to multiply both the side by 10, because here a bar is on a single digit. So by multiplying 10 on both sides, I will get 10x equal to 10 multiply 0.4777. If I simplify it, my answer will be 4.777, and it will go on. Now very most important step, I have to separate this number in such a way that I can use x here. So let me write x as it is, and that is 0.4777. Now here you can see the first digit after decimal is 7, and here I have written 4. So I have to add 3 more after the decimal. These whole numbers are the same, right? 777. Here we have changed only first digit after the decimal. So I have added 3. 3 plus 4 is equal to 7, right? And here I can write 4. 4.3 plus 0.4777. If I add these two numbers, I will get 4.777. So here 10x, here again 10x equal to 4.3 plus. I can write x instead of this number, because we have assumed that. Now put x on this side. So 10x minus x equal to 4.3. 9x equal to 4.3. So x equal to 4.3 divided by 9. Now if I remove the decimal point, my answer will be 43 by 90. So this is in the form of P by Q, and this is my answer. Now for third one, 0.001. Now first step we have to assume it. Let x equal to 0.001001, and it will go on. Now we have to multiply both the side. Here we have bar on 3 digits. That means we have to multiply by 1000. If here bar is only on 2 digits, we will multiply it by 100. But here we have 3 bar on 3 digits, so we will multiply it by 1000 on both the sides. So 1000x equal to 1000 multiply 0.001001, and it will go on. If I simplify it, answer will be 1000x equal to, if I multiply 1000 into this, my answer will be 1, 2 and 3. So 1.001001, and it will go on. Right, now I have to separate it in such a way that I can use here. Now in this question it will be very easy, because after the decimal point you can see 0.0010010001, and our x is also 0.0010010001. So just simply write 0.001001, and here 1 plus this equal to this, right? Here we have 1000x. Now you can write x instead of this, because we have assumed it already. Now if you take x on this side, it will become minus x. If you subtract it, answer will be 999x equal to 1. Now x equal to 1 upon 999. This will be your answer. Now our fourth question is, we have to write p by q form of 0.9999, right? And it will go up to infinite. I can simply write it as 0.9 bar. Now we know the method, right? In the first step we will assume that let x equal to 0.999. Now we have bar on a single digit, so we will multiply it by 10. So by multiplying 10, I will get 10x equal to 10 multiply 0.999. Now if I simplify this, my answer will be 9.999. Now very most important step, I have to separate this number in such a way that I can use x here. So let me write x as it is, and that is 0.999. What number I have to write here? To in such a way that if I add these two numbers, my answer will be this. Simple. I have just add 9. Now here 10x as it is. So 10x equal to 9 plus x, because I can write x instead of this. Now if I put x on this side of equal to sign, it will be minus. Now if I subtract x from 10x, my answer will be 9x equal to 9. So x equal to 9 divided by 9. If I cut this, my answer will be 1. So here you can see value of 0.999 is equal to 1. Is it in the form of p by q? Yes. 1 divided by 1 or 9 divided by 9, it is in the form of p by q. So why the value of this becomes 1? Because in the number line, let us see that here we have 0 and here we have 1. Now if I write the numbers that comes between 0 and 1, so first is 0.1, 0.2, and here 0.9. Now if you zoom in this section, 0.9 and 1. If I start writing the numbers between these, 0.91, 0.92 up to 0.99. Now again if I zoom this section, here I have 1, here I have 0.99. If I start writing numbers between these two numbers is like 0.991, 0.992 up to 0.999. Now again I zoom in this number. So if I do this step for infinite time, the number is 0.99999. The next number, very next number after this is 1. So if you see on the number line, it is very close to 1. We can say a nearest number to the 1, right? So we can take a value of 0.999 is equal to 1 in the form of p by q. Now here we have question number 5. The question is, we have to find the maximum number of digits that can be in the repeating block of decimal expansion of this number. The question is, if I write the decimal expansion of this number, let me assume the decimal expansion of this number is 0.125, and here we have bar. So the number of digits that are repeating in this repeating block is 3. If the decimal expansion is this, the number of digits that are repeating in the repeating block is 5. So I have to find the maximum number that can be in the repeating block of decimal expansion of this number, and that is 1 by 70. The simple trick is, the maximum number that can be in the repeating block of any p by decimal expansion of any number that is in the form of p by q, the answer is q minus 1. Max number of digits can be in the repeating block of decimal expansion, right? So answer will be q minus 1, where q is denominator. So here answer will become 16, because we have denominator as 17. P by q, here q is 17, so our answer will be 16. 16 is the maximum number that can be in the repeating block of the decimal expansion. If you do decimal expansion of this number, the answer is 0.05. I have written it because I don't want to do this much of division. 5883235294117. You can simply do division and you will get this answer, right? Here is our answer, and here you can see 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. 16 digits are in repeating block of decimal expansion of this number. So here is our question number 5. If you have ever asked that, if you have given a number in form of v by q and you have asked the maximum number that can be in the repeating block of decimal number, you just write, you can just write q minus 1, where q is denominator. Here you can just write 16. Now we will move on to the sixth question. Now here is sixth question of exercise number 1.3. First they ask you to look at the rational numbers of form p by q with only common factor 1. Let me give a few examples. P by q, now 2 by 3, 2 by 5, now 13 by 10, now I can write 15 by 2. Here I have 4 examples. Now if I do a decimal expansion of these numbers, answer will be 0.6 bar. For this answer will be 0.4. For this answer will be 1.3. For this answer will be 7.5. Now, if you notice, I want a terminating decimal examples, terminating decimals, right? Expansion. For the terminating decimal expansion, here I have 3 terminating decimal expansions. If you notice a denominator of these 3 numbers, here I have 5 only, here I have 2 only, and here I have 10. If I do prime factorization of 10, I will get 2 multiply 5. So a trick to get a terminating decimal expansion is, in the denominator you can only have 2's or 5's or 2 and 5's. What I am saying is, you can write any number in place of numerator, but in place of denominator, that means in place of q, let me write 20 here. I want to find whether this, I can write any number here. I want to find whether this number is, let me write 11 here, whether this number is terminating or not. I just have to do a decimal expansion of denominator. So if, I just have to do a prime factorization of denominator. If I do this, my answer will be 2 multiply 2 multiply 5. Now check it. If the prime factorization of denominator contains only 2's and 5's, that means this is terminating. Here we have 2 and 5, so this is terminating. If any other number like 11 by 23, if I do prime factorization, now this will be, let me write 11 by 22. Now if I do prime, I want to check whether this is terminating or not. If I do prime factorization of denominator, that is 22. So prime factorization of 22 is 2 multiply 11, no other factor. So 2 multiply 11, here we have 2, but 11 is also present here. So the condition is you can only have 2's and 5's. 11 cannot be here for the terminating. So the answer of this number is, decimal expansion of this number is non-terminating. Let me give another example. Let us take 11 by 25. Now if I want to check, I have to check the prime factorization of denominator, that is 5 multiply 5, right? So if I do 5 multiply 5, here we have 5's only. That can be done in, that can be in the form of terminating decimal expansions. What I have said, we can have 5's only, or 2's only, or 5 and 2's only, right? 5 and 2 in multiple form. So this is will be also a terminating decimal expansion. This is not a terminating decimal expansion, it is non-terminating decimal expansion. So if ever you ask that property to satisfy for q to be a decimal expansion in form of terminating, you can write as prime factorization of q should contain powers of 2 and 5 only. What I mean by this sentence, if I get 20 in the form of denominator, I can write 2 power 2 multiply 5. So I got the power of 2's and 5's only. If I write 30, prime factorization will be 2 multiply 3 multiply 5. So here I get 3 extra that cannot be present to get a terminating decimal expansion. So it will be also wrong. Now if you want to find a reason behind this, just think. To get a terminating decimal expansion, simplest form will be you can get 10 in the form of denominator or 100 or 1000 or any number like this, right? Let me write 99 divided by 100. So the decimal expansion of this number will be 0.99. Very easy, and it is terminating also to get a terminating decimal expansion, right? Now to make 10 or 100 or 1000 or 10,000, the easiest way is like I have 2 here and I want to make a 100 here. I will just multiply it by 50 and divide it by 50. 50 to the 100, right? If you multiply and divide by same number to any number in form of p by q, the answer will be same, right? So to get 10, 100, 1000 or 10,000 easily, you can find only common factor that can be multiplied and divided. It is 2 or 5. If I have 1 by 5 and I want to make it 10 in the form of denominator, I will just multiply and divide it by 2. Value of this will not be changed, but I can get easily answer, that is 0.2, right? If you divide 1 by 5, the answer is only 0.2. So this is the reason behind it. To get 10, 100, 1000, 10,000 or any other, you just can use a 2 and 5 only. So the decimal expansion, if you want decimal terminating decimal expansion, q should be contains power of 2 and 5 only, right? Now we will move on to the seventh question. Here we have seventh question. The power of sorry, we have to find three numbers that is non-terminating and non-recurring. You can write any three numbers. This simply means that I have to write three irrational numbers. You can just write root 2, root 3 and 5. Or if you don't want to write this, you can just write 1.123 and it will go on 2.123, 3.123, right? You can write infinite number that is non-terminating and non-recurring. Let me write 0.1001, 100, You just have to mention three dots that represent that it is non-terminating and no bar for mentioning that this number is non-recurring or non-repeating, right? Now our eighth question is, we have 5 by 7 and 9 by 11. We have to find three decimal expansions that is non-terminating and non-repeating between these two numbers. So first we will do decimal expansion of these two numbers. For 5 by 7, my answer will be 0.71428 5, right? The decimal expansion of 5 by 7 will be this. Now for 9 by 11, the decimal expansion of 9 by 11 will be 0.818181, right? So I have to find three numbers between these. Just simply write, you have to see that you write a number between these two numbers, right? So I can write 72. Now the 72 will be between these two numbers. Now here you can write 1, 2, 3, 4, 5, 6 and it will go on. This is non-terminating and non-repeating and also comes between these two numbers. Now 4, 7, 3, 1, 2, 3, 4, 5. This will also come on between this number. Now 7, 4, 1, 2, 3, 4, 5. This also comes between these numbers and these three numbers are non-terminating and non-recurring. So here we have shown question number 8. Now we will see question number 9. Now here is our question number 9, the last question of exercise 1.3. we have to check whether these numbers are rational or irrational, right? Now I have told you earlier that to find whether the given number is rational or irrational, you just have to check the decimal expansion of that number. If the decimal expansion is terminating, that means their number is rational. Now if the decimal expansion is non-terminating, you have to check whether it is recurring or not. If the decimal expansion is non-terminating and it is repeating, that means it is rational number. The only case for irrational is non-terminating and non-repeating. Now for the first, square root of 23, it is irrational because for the square roots, here you can see 225, or you can say 225 is a perfect square number. So square root of perfect square numbers. Square root of perfect square number is only a rational number. Any other square root except perfect square number is irrational. Square root of 0 is 0, square root of 1 is 1. These both cases are, you have to remember that these both are rational number. Any other number in the square root and the number is, if the number is not a perfect square, let me write 49 here. This means the answer will be 7. This is rational number. So if the square root of perfect square, it is rational. If a square root of a not perfect square, it is irrational. Only these two number you have to remember that under square root of 0 is 0 and square root of 1 is 1. These both number are rational. So here we have 23. 23 is not a perfect square number. Square root of any number except perfect square number is irrational. So the answer is irrational. For 225, 225 is perfect square number. Square root of 225 is equal to 15. So the answer is rational. It is a rational number. Here you can see decimal expansion, it is terminating. That means it is a rational number. Here you can see 7.478478 and it will go up to infinite. Decimal expansion is non-terminating. Now if you look at the decimal expansion, here you can see 478 repeats itself. So it is repeating and non-terminating, right? So we have, this number is a rational number. Now for this 1.1010101300 now this is non-terminating, as we can see. Now if we look there whether this is repeating or not, this is not repeating, as we can see. So non-terminating and non-repeating, that means this is irrational number, right? So here is a complete exercise 1.3. Thank you for watching this video. Now we will meet in the next video.